So this question says that we have a 30 centimeter long string with one end clamped and the other one free to travel transversely, and is vibrating at its second harmonic. What's the wavelength of the traveling waves? So I know that by clamping at one end and the other one is free, that I have an open-closed situation. I'm going to draw two of these because my lowest one has clamped at one end and it's open at the other, which means we have to have a node at one end and an antinode at the other. And the lowest one that I can draw is where the string on this end vibrates up and down and this point is fixed. So it's going to vibrate between the top and the bottom. So if I look at this, I could continue out and I'll see that this right here, this total length L, is equal to a quarter of the wavelength. Right? I go from 0 to max, I go back to 0, I go to a minimum and back to max. So this wavelength that I get, this length right here is only a quarter of a wavelength. The second harmonic, which would be the next one we're able to put in here, is going to be a little bit different. It's going to go to a maximum, it's going to go back to 0, and then it's going to go to another maximum. So if I look at this, if I were to extend this out, this right here, this full length would be one wavelength, which means in this case, L is equal to 3/4 of a wavelength. Or that the wavelength is equal to 4/3 L, which is equal to 4/3 times 30 centimeters, because that's what my value of L is, which gives me a value of 40 centimeters. So I get my choice C being the right answer. So I looked at the second harmonic. This is the one that's in red. And I just figure out how many wavelengths that I had inside the tube. So the string will go up, go back to a node again, and then go to an end at an antinode. Starts at a node, ends at an antinode.